Good morning, dear students. Today we will revise the ionic bond and how it works in the compound. The octet rule that you know very well. Atoms tend to gain, lose or share electrons to try and have 8 electrons in their outer shell. So octet means 8. Noble gases are non-reactive because they have 8 valence electrons, and that's what they are noble in nature. So they don't need to gain or lose the electron. Ionic bonding. The bond, it is the actually attraction force between the two atoms, two molecules, may be same, may be different. And the ions which are formed by taking or by giving the electrons, that is nothing but if they donate the electron for the bonding, then it is the act as a cation, and if they attracts or they take the electrons from the neighbor one, then it is to be anion. Ionic bonding is all about bonding by gaining or losing the electrons to achieve a full outer shell. Valence electrons means electrons in the outermost shell. We use these to help with bonding, and maybe sharing and maybe giving that electrons they lose, or they can take that electrons from the nearest atom. Definitions. See, ion means charged atom that has gained or lost electron and has a positive or negative charge over it. Cation means ion with positive charge. It means it donates the electron for the bonding, and anions mean ion with negative charge which accept the electron for the bonding. Ions. An ion is an atom that has gained or lost one or more electrons and has a positive or negative charge, that you know now. Atom gain or lose electrons in order to achieve the octet rule. It means to complete the 8 electrons valence electron in the outermost shell. Note that when you see a positive charge over it, the atom is losing an electron for bonding purposes, and when you see a negative charge over an atom, it means it is gaining an electron for the bonding. See now, this is the overall chart of the periodic table, that is the metals, non-metals and the metalloids. Metals are in between, which are having that the yellow color. Then pink color, it is metalloid. It is for only your convenience. And non-metals are green in color. So they are right inside, and that are hydrogen. Metal elements. Nearly all metals form cations. So metals are positively charged, they conduct electricity, and they are always tend to give the electrons and achieve the central position. Remember, this is also very important. Magnesium has 2 valence electron in its outermost shell. It is much easier to lose that 2 outermost electrons and then gain 6 electrons from the outermost, and therefore magnesium carries the 2 positive charge and complete its uh, octet, and that it becomes a neutral in nature. Non-metal elements. Nearly all non-metal elements form anions. Oxygen has 6 valence electrons. It means in its outermost shell 6 electrons are there. It is much easier to oxygen to gain 2 electrons than to lose 6 electrons, and therefore oxygen carries that 2 negative charge, that is the anion. Naming a cation, positive ion, atoms that lose electrons, simply the name of the element is, listen, that sodium, it is positive charge having that 1 cation, that means sodium ion, sodium cation. Magnesium has that 2 positive charge, that means magnesium cation, magnesium ion. Ion names, naming an anion, negative ions. Atoms that gain electrons is an anion. The element name ends in a IDE. It means chlorine, which carries 1 negative charge. Its name is chloride ion. Oxygen, which carries 2 negative charge. So it means oxide ion. So anion which is ending with that IDE. Ionic bonding. The force of attraction between a positive charge and a negative charge creates the ionic bond. Example, see, wants to be a neutral, sodium ion which has that positive 1 charge, that, and chlorine ion which has a negative charge. So sodium loses 1 electron and chlorine it accepts 1 electron, and there is the, it becomes a neutral in nature. So sodium chloride, which is a table salt. Ionic bond, electrons are lost or gained resulting in the formation of ion in ionic bond. See the example of potassium and the fluorine. Potassium, it has that 1 electron, and fluorine which has a 1 electron in its outermost shell. So that the out of 7 electrons, 1 is the single electron in fluorine. So that potassium, it can lose that electron, and that the fluorine which accept that electron to complete its octet. So the electron from potassium, it becomes ready to donate that electron, and fluorine which accepts that electron. When that potassium is losing that electron, it overall carries that 1 positive charge, and fluorine which carries that negative charge due to accepting the electron from the nearest potassium ion. So potassium becomes a cation and chlorine becomes an anion. So potassium and the fluorine which is forming that ionic bond by exchanging the cation and the anion. The cation ion goes first, then the anion. Remember, when naming an anion atom that gains electrons, it will end in IDE. So NaCl, it becomes a sodium chloride, MgO, that is magnesium oxide. It means sodium and the magnesium are cations and chlorine and the oxygen are negative. So it ends with the IDE. So sodium chloride and the magnesium chloride, the name it forms. The compound potassium fluoride consists of potassium K plus ions and fluorine F minus ion. The ionic bond is the attraction between the positive potassium ion and the negative fluorine ion. Thus, it forms that ionic bond. It is very important where that the elements, compounds, they are to be acting with itself. Thank you. Thank you very much. It's COVID-19 coronavirus care time. Use mask and keep the social distance whenever you are coming out. Thank you. Thanking you. Thank you very much.